Let me introduce myself to you. I'm Dr. Rajani P, working as Assistant Professor, Department of Chemistry, NSS College, Nilamel. Today, I am explained development and application of green synthesized alpha MnO2 nanoparticle using the plant extract Centella asiatica for the degradation of malachite green in the wastewater treatment. Let's have some introduction about, all of us know about what's a photocatalyst and the role of photocatalysis in the today application and wastewater treatment, and the importance of nanomaterials uh, for this purpose. When lot of nanomaterials are used for this purpose, especially metal oxides. And here I take manganese oxide as the nanomaterial for the degradation of wastewater treatment. And the important one is that manganese oxide synthesized by a green synthesis method, and there is some advantages over conventional methods. And the green synthesis method, we use the plant extract for the synthesis of manganese oxide. And here the brief description about how the materials and methods for the preparation of alpha MnO2 nanoparticles. And the plant extract, that is the common name is cotangal, and Centella asiatica is the botanical name. And this plant extract is taken and washed with the distilled water and collect the extract, and to that plant extract we add through burette 1 millimolar potassium permanganate solution is added, and it's allowed to vigorous stirring under 2 to 3 hours. And material obtained is filtered, washed and dried and annealed at 600 degrees centigrade at about 3 hours. And the annealed material is used for the characterization techniques like XRDism, FDIR, like that. And this is the XRD pattern of the obtained material. And from the XRD pattern, it is clear that the obtained material is alpha MnO2. All the peak is well agreed with the reported Jessipedius files, and no additional peaks are there. All these are agreed with the alpha MnO2. So the obtained material is alpha MnO2. And from the XRD pattern, we can calculate the particle size using the Scherrer formula. And here we also calculate the particle size, and it is to be observed that it is approximately, it is 14 nanometer. And here it is the sum image, and followed by term image. And the sum image clearly indicate the morphology of the obtained material. And here is a needle shaped morphology, and this morphology, very interesting morphology. Particles are uniformly distributed and having a definite morphology, and the needle shaped morphology is clear by the term image also. It is a one needle. The term image of a one needle is given below, given this in this slide. And then it is the FTIR spectrum. And from the FTIR spectrum, there is a metal oxygen structuring is there, and in addition to that, 2 peaks are available. And this is due to the OS vibration, because water molecules are there. Maybe occluded water molecule or surface water molecules are there. That is these 2 peaks are that. No additional peaks in this FTIR spectrum from this plant extract, because plant extracts contain a lot of functionalities. And next is the UV visible spectroscopy, and study UV visible spectrum. And the prominent peak is observed here. And by taking the top plot and calculating the band gap, and it is a 2.7 electron volt is the band gap of the material. And this material is a very good for the UV. It is a very good catalyst under UV light, and that is why we taken the photocatalytic activity. And the dye choose this malachite green. Malachite green is used because it is used as a textile industry. That is, we choose malachite green. And here it is the effect time degradation time of the malachite green with the catalyst. And it is clear from the graph, it is clear that as the time increases long, the degradation of the malachite green is absorption pattern is reduced, and that is the malachite green is degrade when we radiate it with the UV light and as the time goes on. And there are a lot of parameters we checked to study the degradation efficiency of this material. And the first one is the catalyst amount, effect of catalyst amount on degradation. And it is to be noted that as the amount too much increases, the catalyst degradation efficiency decreases, and it is an optimized approximately 0.1 gram, 0.1 gram. The efficiency of the catalyst is maximum, and after that it is not increasing too much. That is the degradation efficiency with the catalyst. In addition to that, we can control the material by we can check the pH of the material, where pH degradation efficiency by using pH. All the parameters are studied, and it is understood that the material is a very good catalyst for the degradation of dyes, because this photocatalytic activity is very important and day-to-day nowadays. And finally, I conclude that we have prepared a very simple method by eco-friendly method and a not toxic method, environmental method, a green synthetic method we adopted for the preparation of alpha MnO2 nanoparticle. And some studies suggested that a thread-like needle-like morphologies for obtained alpha MnO2 nanoparticle having and from the XRD you get an average particle size of 14 nanometer, and it is used as a very good catalyst for the degradation of malachite 3. And thank you.